Chapter 9. So chapter 8 had almost this first part of the notes for chapter 8 almost looked identical to this. The only difference is instead of hypothesis tests, it said confidence intervals. And then confidence intervals instead of tests, right? It's the same thing. A lot of what we do today, this chapter, is what we did in chapter 8. That's why I told you guys at the beginning of the semester, I'm like, we have quite a few chapters to cover, but they're just going to roll. You know, chapter 8 was really fast. Chapter 9 is going to be really fast. Chapter 10, we come back to confidence intervals. Chapter 11, I believe, is hypothesis tests. And then chapter 12, we're done. Okay, so a lot of this stuff is very much related. Okay, so the other part, besides confidence intervals, is what we call a hypothesis test. Hypotheses test, that's bad grammar, I think. It should be hypotheses tests. Hypothesis, what is a hypothesis? There you go. What we think is going to happen, right? We don't know what's going to happen for fact, but judging by what I've seen in the past or what I know, this is what I think is going to happen, right? And a test is not like a test like you take a test. It's a test to see if it's true or not, right? That's how you tell if something's true or not, okay? So for today, we're going to focus on, or today and tomorrow, we're going to be focusing on this for the next few days. One sample z-tests for proportions. So there's only proportions that we're talking about to start. And then we'll end the chapter with means, just like we did last chapter. Okay, so we've seen a lot of symbols so far. All of these symbols we've seen, some throughout the semester or through the year, some popped up later on this last couple chapters. But these are the symbols that we've seen. So it's important to know. You guys do a pretty good job of knowing when to use them and what they are, right? If we have mu, that's the true population mean, right? That's the population mean. We have p, that's the population proportion, right? This guy right here is the true population standard deviation. And then we have our samples, right? Mean and proportion, and then this is a sample standard deviation, right? We've seen all of those before. Today, we're going to get a couple new ones. 3 of them, to be exact. 3 new symbols. Okay? The first one is H sub 0. It's called the null hypothesis. Okay, it's called a null hypothesis. The symbol is H sub 0. Okay? What is being claimed? Okay? The null hypothesis is whatever is being claimed in the prompt that they're telling us. They're always going to claim something, right? That's what this is. The next one right below it that looks like ha is actually the alternative hypothesis. Alternative hypothesis. It counters what they've told us. If we think something's fishy or we want to test, we're going to be testing this guy here to see if it's correct or not. Or not necessarily to see if it's correct, that's a bad way to say it. To see if we have enough information to say it's wrong. All we're looking to do is to see if this is what they've told us is wrong. We're never going to say you're right. You know what? You're right. But we will say, you know what? We don't have enough information to say you're right, or to say you're wrong. So we can't say you're wrong. We never say you're right. We just check to see if they're wrong. Okay? Okay, so, and then the last one is alpha. Alpha is a significance level for hypothesis tests. It's the level we have to meet to say that their claim is wrong. Okay, so the lower the alpha level, we'll talk about this more, but the lower the alpha level, the higher the burden we have to prove. Okay, so let me say that again. The lower the alpha level, so the smaller the alpha level, the more evidence I need to determine that the claim is wrong. Okay? It's kind of counterintuitive. You think as it goes up, it's more, but no, it's actually as it goes down, it becomes more. If I want to be able to, my goal is to reject the null hypothesis. If I reject the null hypothesis, that means I have enough evidence to say, no, that's actually wrong. There's not that. Okay? The lower the alpha, the more evidence I need, right? In a court, this is kind of like in a court of law. In a court of law, what is the burden of proof? What is the how do they tell the jury when to vote guilty? When what burden has been met? Does anyone know? You guys have probably heard it sometime, but it might not come to you. So when in a jury trial, when you turn 18, you become available for jury duty. Okay, so they call you in, and then if they like you, they ask you questions. Each side, the defense and the prosecution, will ask you questions, and if they like what you say, they'll pick you for the jury. And when you're in the jury, you really are deciding guilty, not guilty. Okay, that's your job, to listen to the evidence and objectively say guilty, not guilty, to the person or people who they say have committed the crime. When can they say guilty? Okay, so when can you vote guilty? I'm talking about like individually. Yeah, you're right. The person is guilty when everyone has said guilty, right? When can I legally, when can I turn my not guilty to a guilty? Not when that's not very reassuring. If I'm on the jury, if I'm on for my life, and it's just like, oh, when I want. When is it? Does anyone know? You've heard it before. You've heard it before. I know if I say it, you've heard it. Yeah, you all discuss it. But when should your vote, if at all, go from not guilty to guilty? When? Exactly. When what though? When starts with beyond. Close. Beyond. There you go. Beyond a reasonable doubt. That's the burden of proof. They say if the evidence should beyond a reasonable doubt that person did the crime, then you vote guilty, right? You vote guilty. If it doesn't meet that burden, doesn't meet that threshold, then you say not guilty. You can't say, I think the person did it. Think is not meeting the burden, right? There's a good chance the person did it. That's not meeting the burden, right? But it also doesn't say that you have to be 100% sure the person did it. It has to be beyond reasonable doubt, right? That's what the burden of proof is. If you vote guilty, okay? That's the evidence level, right? That's kind of alpha level. Alpha level is that threshold where we have to go over. It's kind of backwards though. The higher the amount of evidence needed, the lower the alpha level. So it's kind of opposite what you would normally think. Like, for example, very common is our alpha level to be 5%. 5%. Okay? No, that's an alpha. It's a Greek letter.
Wait, why is it an A on this side?
Which one? This guy right here?
Can you redraw it?
That's alpha.
It's
because it's not an English letter.
Oh, so that's why it was.
It's a Greek letter. That's a Greek letter. Just like this guy right here is a Greek letter. They're just Greek letters. It might look like a letter that you're used to seeing, but it's not an English letter. Like if I was to draw an A, that would be an A. This is a Greek letter. Okay? Alpha. Alpha is the, okay? Just like beta. Beta is drawn like this. That's a B with a tail. If I was drawing a B, right? They're similar because a lot of our lettering comes from Greek symbols, but they're not the same, right? That's delta. We don't have any letters that look like that, right? Okay. Anyway, so getting back to where we were. Alpha. A very common alpha level is 5%. That's the threshold we need to meet. So if I say change that to 1%, that means we need a higher level of evidence. So in other words, if 5% is reasonable doubt, 1% means you have to be almost 100% sure that person did it. That means I need to have at least 3 people who saw the person do it, at least another person who said the person told me they did it, that kind of thing, right? I have to have video evidence of the person doing it. That's not the court of law. Court of law says just beyond a reasonable doubt. Okay? That's kind of like what 5% is. So 1% would be a higher burden. 10% would be a lower burden. Is there more than a 50% chance that the person did it? Yeah, okay. Guilty. Right? So 10% we don't see a lot. 5% we see a lot. 1% we see sometimes. Okay? Because the higher the burden, the lower the alpha level. Okay? Kind of counterintuitive to what you think. All right. Okay, so when do we use hypothesis tests? Right here. When this is the question we want to answer. Could this observed change be the result of chance variance? Or is the change so unlikely that it is considered statistically significant? I'll give you an example. A claim is made. We'll talk about some claims later. I have a couple examples in here, but a claim is made. I take a sample, and my sample is so far away from their claim that it has to be considered statistically significant, right? If my sample is so far away, if I did my sample correctly, and your claim is what you say it is, the chances of that happening are so small that your claim has to be wrong. That's what we're saying. Okay, so that's what we're trying to figure out. Okay, we're trying to prove someone's claim is incorrect based off the data that we have. That's when we use hypothesis tests. We've kind of been doing that. With confidence intervals, right? We've done that with confidence intervals. Now we're going to use hypothesis tests to really answer the same question. In fact, the first example is one we've done before. Okay? Hypothesis tests. The nice part about hypothesis tests is that 5 of the 7 steps are exactly the same as you're used to doing. Okay? There are 7 steps total. Number 1 you've done before. Number 4, 5, 6, 7 you've done before. The 2 new ones are 2 and 3. And they're probably the easiest ones to do because they're really short. 2 and 3 are the very shortest ones. Number 3 will always be stated, or 5%. Number 2 is always stated as well. Okay? The test statistic's a little different though. We're not going to use the same formula we've been using. Okay, it's a new formula, but it's not that bad. Okay, so formula. Test statistic just means it's a fancy word for formula, fancy phrase for formula. What formula are we using? Why is that important? Because it identifies what we're doing. We're doing a 1 sample z-test for proportions. Okay? Conditions are exactly the same as what you did in chapter 8 for proportions. They're exactly the same. I haven't changed 1 word of them. Okay? Okay, so one of the new things is hypotheses. How do we write our 2 hypotheses? We always have a null hypothesis, and we always have a alternative hypothesis. Okay? The null hypothesis is what they've claimed. It's pretty much what they've claimed. So today we're going to see a lot of these today. Oops. We're not going to see any of these today. We're not going to see any means. We're going to see a lot of these today. The null hypothesis, that's what this says. The null hypothesis is what they claim. What do they claim? The proportion is what? That's what we're going to put there. Based on the information, the data we have, we're going to choose one of three options. I think their claim is wrong because I think that the proportion is bigger, the true proportion is bigger than what they're saying, less than what they're saying, or I don't know if it's bigger or smaller, but it's just different. Just different. I don't know if it's bigger or smaller, it's just different than what they're saying.
Isn't that always the safest play to go?
It is the safest play, but it's the hardest one to meet your burden, right? The alpha level. It's hard to meet that burden because I'll explain why when we start doing it. It's called a double-sided two-tail tests, and it's harder to meet the burden. It's harder to prove them wrong. It's harder to say you're wrong with this guy here. But yeah, it would be the safest way to go sometimes. Okay. All right. Significance level can be any value. They'll always tell you the value. And if they don't, use 5%. Does that sound familiar? Think about it. When we exactly, that's where the 5% is. It's the 5% that we didn't use in the 95%, right? 95 was default, right? Last chapter. They're very much the reason why 5% is the default goes with that. And I'll explain more about that this chapter. Okay? 10%, the burden's not as high. 5% is kind of the default. 1% means your burden is really high. If I can prove, if I have this much evidence, it's pretty much you can say with confidence that they're wrong. Okay? For tests that require a higher level of confidence, we use a lower alpha level. Okay? Okay, p-values, more p-values. A p-value is what we get when we calculate. So part of our calculations section is going to calculate a p-value. The p-value will determine whether we can reject or fail to reject the null. Okay, so what does it mean when I say reject something? If I reject something, it is what? It's wrong. It's wrong, right? If I reject something, it's wrong. That's what happens here. If I fail to reject something, do I accept it? No. I fail to reject something means I never accept it. So we never take what they say, even if we don't have enough evidence to reject, we never accept. You never, ever, ever, ever accept. Okay? We always say reject, fail to reject. It's like in court. You'll never hear the jury. The jury reads the verdict. We find so-and-so innocent. You'll never hear them say innocent.
Not guilty.
They'll always say two things. What is it?
Guilty or
Not guilty or not guilty. They will never say innocent.
Oh, that's weird.
Because all they're trying to do is prove that the person did it. Or not prove, but all what the prosecution is trying to do is prove that they did it. Okay? If they met their burden, guilty. If they didn't, not guilty. So not guilty doesn't mean you didn't do it. It just might mean there's not enough evidence to show that you did do it. I don't have enough witnesses to say that you were in the area where the crime occurred, whatever, right? So we never say they're innocent. We never accept. Conclusion. Conclusion, kind of a sentence frame. Here's the sentence frame. Since p-value, and then you state your p-value, is less than or greater than alpha, and then you state your alpha, we either reject or we fail to reject the null hypothesis. Okay, that's the first thing. We always want to compare the p-value with the alpha. That's the first thing. Second thing, because of that, do we reject or do we fail to reject the null hypothesis? And then the third thing is, do we have or do we lack sufficient evidence to suggest that? And then we have to put this in words. The alternative hypothesis in words. In context. Okay, that's your sentence frame. So 2 sentences. 1, 2. Sometimes you can break it up to 3, but usually 2 sentences are good enough. Okay. All right. Interpreting the p-value, sometimes I'll ask you to do that. We'll do an example of this later, but let's get to a test. Okay, so this one should sound familiar. Read it to yourself. So as you're reading it, if you're not done, does it sound familiar? Yeah, if you looked in chapter 8 notes, we did this question, except we used a confidence interval to answer the question. The reason we used a confidence interval is because that's all we had at our disposal. But the way I would really answer this question is with a hypothesis test. Okay? So is it wrong to do it the way we did in chapter 8? No. But this is a better way. Okay? Okay, so a couple things.
That's just like more uncomplicated interval.
It's not it's not an interval. I'll explain it. Let's do the first one and then it'll make more sense.
Sounds a lot like
It is. A lot of the steps are the same, right? Calculations are going to be different though. So it's not actually an interval that we're getting. Confidence interval is we use most of the time we use confidence intervals to predict something. This one we use to say to show that a claim is wrong, to prove that a claim is wrong. Yeah. Okay. But we can use a confidence interval to do this stuff too. It is believed that the vaccine of a horrible disease has been effective on 62% of the recipients. Medical research teams have been tracking this horrible disease and are looking for evidence to see if perhaps the vaccine is now less effective than it used to be. Maybe the disease has evolved, mutated. The vaccine is administered to a random sample of 450 adults, and after following these subjects for a period of 3 months, was found to be effective on 259 of them. Okay, so the first step is always, what do we know? So let's label what we know. Highlight, underline, label, because we're going to need it later. So what do we know right now? What's one thing that we know? Okay, so 62%. What symbol goes with 62%? P, good. P equals 0.62. Actually, I shouldn't write it there because that's where my answer is going to go. No, actually, it's fine. Good, that's one thing we know. What's another thing we know?
N equals 450.
N equals 450, good.
P hat equals 259 over 450.
Good. It comes from an SRS, good. We're going to need that definitely. Yeah, that's a good one. Even though the notes say these are all proportions, you guys know on the tests, I don't tell you whether it's a proportions or a means, right? So the worst thing you can do is look at this on a test and try to do means, right? Because then you're automatically going to get everything wrong, right?
Wait, you don't give us even like half credit?
No.
Even if we did it right. Actually, you can't even do it right because you don't get you have the right.
Exactly. Yeah, it's just like I wish I could, but you use the wrong. You use the wrong literally everything, right? Okay. Anything else that we want to pull from there? I think we're good. All right, so let's go to population parameter. We've done this before. So the true proportion, actually it's word for word what we did in the notes for chapter 8. But what did you can dig them out, or what did we do back then? Let's see, true proportion of, there you go, true proportion of vaccines administered that were effective, or people who the vaccine was effective on. There you go. Something like that, right? The true proportion of vaccine.
True proportion of people for which the vaccine was effective.
There you go. I like that word. Say it again.
True proportion of people for which the vaccine was effective.
True proportion of people for which
the vaccine was effective.
The vaccine was effective. Perfect. There's many different ways to write this, but that's essentially what you're trying to say. If I was going to write true proportion of vaccines administered on these people that was effective, just saying the same thing. Okay. All right, hypotheses. We have two of them. We have the null and we have the alternative. So H sub 0 colon H sub A colon. So for the null hypothesis, That's their claim. What is their claim? P equals,
0.62.
we said that, right? We pointed that out. 0.62. That's their claim, right? We have three options. We can say, no, I think it's actually bigger than 0.62. No, I think it's actually less than 0.62. Or, I don't know if it's bigger or smaller, but it's just different. So yeah, this is a way to tell. There's a couple different ways to tell. The easiest way is they'll kind of lead you in that direction. Read the question. Do they tell us which one they want us to test? Which way?
Yeah, has less effective.
There you go. That's the way they want us to test. Most of the time, they will tell you in the question. They'll say less or more or just different. Okay, and that's the key to that one. So we want to go less than. If it's become more effective, is that a problem? If the vaccines become more effective over time, is that a problem? That's not a problem at all. Like the COVID vaccine is 95%. If it's really 99%, I don't think anyone's going to have a problem with that. But if it's really 70%, I think a lot of people are going to have a problem with that, right? So more is okay. Less is not okay with vaccines. Okay. Did they tell us anywhere in there about significance level or no kind of level? So we're going to use our default. So our default is 0.05 or 5%. Okay. Those are the only two. Everything else is the same. So let's go to the next one. Conditions, assumptions. Literally word for word what we did back last chapter. So first one was SRS. Second one, 10% condition. And then the last one, normality. Okay. Okay, so SRS stated. Number two, 10% condition. 10% condition, big N, sorry, little n is less than or equal to 10% of big N. We know little n is 450. 10% of big N. Do we have a number for big N? So what do we put?
All vaccinated people.
There you go. All vaxxed people. Okay. And the last one is normality. Remember, this is not, we don't use the central limit theorem for this one here.
Oh, you're right.
We have different criteria, right? That's right. A couple slides above, a couple pages earlier, right there. This guy right here. N times P greater than or equal to 10, N times 1 minus P greater than or equal to 10. Okay, so N times P, N is 450, P was 0.62. That's 279. That's definitely bigger than 10. Yep, it's looking like that. 450 times, what is that, 0.38? Yeah. 171? I haven't graded them, but the tests from last time, you guys did a better job of your assumptions, not hiding them in the corner, getting them, you know. Every chapter that we use them, like I told you guys, they tend to, from past experience, they tend to get smaller and smaller and smaller, and eventually you can't read them on some tests. But you guys didn't do that. You guys kept them big. Some of you kept them very big, which I was happy with because I can read them. It's nice and easy to read. Okay. All right. So this is our test statistic we're going to use. Does it look familiar at all? The bottom definitely looks familiar. The bottom is on your formula sheet. And we've used it before, right? It's the standard error of the mean.
Yeah.
Standard error of the mean, which is on your sheet as well. So you don't, on your formula sheet, so you don't have to memorize that guy. And the top is just p hat minus their claim. It's p hat minus whatever they claim. So it's not hard. You don't have to memorize this thing. A lot of people do I have to memorize the whole thing? Well, no. You just have to remember it's p hat minus their claim, and then the bottom is on your sheet. Okay? So it's not going to give us an interval. It's actually going to give us a z-score. Okay, so the first thing we're going to do is we're going to draw our picture. Because if we have z-scores, okay, so when I draw my normal curve, what's in the middle? The mean. What's the mean for this question here? 0.62. Yep. P. P is the mean. Okay. So now let me crunch some numbers. Z equals what was my p hat? Do we know what p hat is?
0.5755.
There you go. We didn't calculate it, but some of you guys did. 0.575 continue, so we'll go 0.576. Minus 0.62. And then the bottom is 0.62 times 1 minus 0.62 divided by 450.
So is there like a fun way?
Fun? What are you talking about?
Like an easier way to do this? Is there a calculator way to do
Yes, there's a calculator way to do it. So p hat is somewhere over here, 0.576. Which way are we shading for p hat? Left or right? How do you know?
Because we want it less than 6.
What did we want less? You're absolutely right. What did we want less?
The true probability.
The hypothesis. Our alternative hypothesis was less than, right? So we're only curious in less than. So this is what we want here. Okay. Okay, so Aldrin asks, is there a calculator way? Absolutely. And I'll show you that right now. Okay? But this is the work I need to see. Once you show me this work, once you show me exactly this picture, this work, then you can use the calculator. Okay? Okay, so let's go to the calculator. Let me pull mine up. Yeah, you can kind of guess where it's going to be.
Yeah, I feel like there's one.
Yeah. It's going to be stat tests, just like where the intervals were.
The very first one just says Z.
Well, yeah, let's go over which one it is. I can't remember which one it is, but once I look at them, we can whittle them down. It's going to be a test, right? So we're not looking for interval this chapter. This chapter, we're not looking for interval unless it asks us for an interval, and it doesn't. It didn't. Okay, so here we go. Stat tests. So we're looking for tests. So the first one is a z-test. Well, that one might be. Well, let's see if we can find a better one. 3 and 4 say 2 sample. That's not what we want, so definitely skip that one. Number 5, a 1 proportion z-test. That sounds a lot closer than what we had, right? How do you know? Look at the first page.
Z-tests.
1 sample z-test proportions. Right there, word for word, right? That's the one we want. That is the one that we want for this specific question. Okay. So number 5, hit enter. P hat, or sorry, not P hat, P sub 0 is their claim. Another way of saying P sub 0, sometimes we'll have P sub 0, it's the claim. Just like H sub 0 was the claim, P sub 0. Their claim was 0.576. No, 0.62, sorry, yeah. There you go. Now, where do I put in P hat? They want to calculate P hat, okay? So X is the numerator, N is the denominator for P hat, okay? We want less than, right? Less than. So we're going to go to the middle one. Middle one is less than. That's the one we want to. There are 2 different options. One is calculate, one is draw. I'm going to show you calculate first. So go down to calculate. Okay. So let's write a couple of these down. Gives us a couple things. It gives us a z-score. The z-score it gives us is negative 0.14, 0.94, sorry. That's the z-score here. It's negative because it's less than the mean. Right below it, they say p equals. That's the p-value. That's what we call the p-value. It's not p like proportion, it's p-value as in probability. So write this down. P-value equals, I'll explain what that means in a second, 0.0260. And then it says P hat and N, right? Okay. Let me show you what the other option is. If you hit, instead of calculate, let's say you hit draw. Everything's the same. Sometimes it's just a matter of preference. It should look like the picture we already have drawn, right? And it gives us the same numbers. The z at the bottom, z equals negative 1.94, and then p equals 0.026, right? It's really preference, which one you prefer. Okay. Okay, so now let's get to the meat of this. The meat of this is the p-value and the conclusion. The p-value, probability value. What do you think that represents? We're going to compare it with the significance level, yeah. But what it means is it's the proportion or probability of the yellow, right? We've done that before. That's what the p-value is. So you've been calculating p-values forever. We just didn't call it the p-value. Negative 1.94, yeah. Underneath it? Okay. Yeah. Yeah, I see what you're saying. Okay. So is that a big percent that's in the yellow? Is it a big or small percent? Extremely small. Extremely small. So now our last step is we are going to compare this guy versus our significance level, our alpha level. Okay, I don't know why this one, I think it got put in the wrong spot. So skip the slide and go to this one down here. Remember, conclusion needs to cover 3 things. That's the one you need. You can combine sentence 1 and 2 if you want, or you can just put 3 things. Okay. There's also, remember earlier I showed you the sentence frame. There's also a sentence frame that you can use right here as well. That's the one we're going to use. Since the p-value, that's how we're going to start. Since the p-value And then we're going to put the p-value. What was the p-value again?
0.0260.
Good. And then we're going to compare it to the alpha level or the significance level. What was the significance level on this one? So is this one less than or greater than? Okay, so we're going to put less than alpha level of 0.05. That's one thing. Next part of it says we reject or we fail to reject. Okay, so we're going to choose one of the options. Again, this is the one where students get wrong sometimes. When do we reject and when do we fail to reject? Well, let me show you right here. Okay. We reject when p-value is smaller than alpha. When p-value is smaller than alpha, we reject. In other words, if p-value can fit inside of the alpha, right, you reject. If it's vice versa, we fail to reject. Okay, so on this one, the p-value is smaller, right? So we reject. So we reject the null hypothesis. So one more time. If the p-value is less, we reject. If the p-value is greater, we fail to reject. Okay. Do I have that somewhere on here? I used to color code it, but I don't think I ever. Let's write it here. Less, greater.
You kind of had that, but it wasn't color coded.
Yeah, I used to have it color coded. I don't know why I didn't. So less than we reject, greater than, fail to reject. Okay. So we reject, one more time. We reject when the p-value is smaller than alpha. Alpha is our level. We need to our burden of proof. If we're under our burden of proof, we've met the burden of proof. Okay, that's why we rejected it. Okay, the last part is we just say, therefore, we just kind of sum it up. Therefore, we have sufficient evidence or significant evidence or sufficient to suggest that, and then we have to put the alternative in words. Well, the alternative we have, but it's in symbols. We have to put it into context. So let's go back to the alternative. The alternative was that the true proportion is actually less than 0.62. That's what we got to say. That the true proportion of effective vaccines is actually less than 0.62. Okay. It suggests that the true proportion of vaccine effectiveness is less than 0.62. Okay. So last thing, Trust me, this is what gets people going. People messed up all of the time. So let me color code mine a little better. Okay. So if the p-value is less than the alpha level, or the p-value is greater than the alpha level. Okay. So let's start with less than. If it's less than, we reject and we have, just like we just have on this one, right? If the opposite is true, if the p-value is too big, then we fail to reject and we lack significant evidence. I'm supposed to say significant evidence. Significance evidence doesn't. It's not proper English. Okay? So that's how you're going to know. If the p-value is smaller than the alpha level, you reject. If we reject, then we have enough evidence, sufficient evidence. If the p-value is too big, if it's bigger than the alpha level, we fail to reject and we lack evidence to say. We never accept. Notice nowhere in there does it say accept. It just says we lack the evidence. Okay, this should be significant. Okay, one last thing. Oh, we can do that later.
Nice.
We'll do that tomorrow. One last thing. Let's say my alpha level was 1%. Would I still have the same conclusion? No, right? If my alpha level went down, that's a higher burden of evidence that I needed. I don't have that much evidence, right? But for 5%, I'm okay. All right. Yeah, we'll interpret the p-value first thing tomorrow, and then we'll do the other practice problem.
Isn't the p-value just the chance that it's lowered?
Yeah, pretty much.